Hello there, and welcome to the Sleepy Space Channel. There is a place in the night sky that is the brightest and most crowded region of our entire galaxy, and yet you have never truly seen it. The center of the Milky Way blazes with the light of millions of stars packed into a small space, but a curtain of dust hangs across the whole distance between us and it, dimming that brilliance to a soft and clouded glow. Behind that veil, hidden from ordinary eyes, sits something stranger and stiller than any star. Tonight, we travel slowly inward, through the crowd and the clouds, to find out what is really hiding at the heart of our galaxy. If you find these quiet journeys worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is something you need to carry. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away behind you. Let's begin. Part 1. The direction we rarely look. Everyone has seen the center of the galaxy, even if they never knew it. On a clear and moonless night, far from the lights of any town, a faint band of pale light stretches across the whole sky. It is soft and uneven, brighter in some places and thinner in others, and it arches from one horizon to the other in a long and quiet ribbon. That band is the Milky Way, seen from the inside. It is the combined glow of many hundreds of billions of stars gathered into a flattened wheel, viewed edge-on from a seat near its rim. And one stretch of that band is brighter and thicker than all the rest. It swells outward into a wide and clouded glow, dense with stars and streaked with dark lanes. That swelling is the direction of the center. To look toward the heart of the galaxy is simply to find that thickening light and to understand that behind it lies the place that everything else is built around. It is a strange thing to realize. The center of the galaxy is not a distant abstraction, not a number in a textbook or a smudge in a photograph. It is a real direction in the real sky, one you can point to on a summer night with your own hand. It sits low toward the south for those in the northern half of the world, in the richest and most crowded part of the Milky Way's band. The ancient stargazers who looked up at that glow had no way of knowing what lay behind it. They saw only the brightest patch of the night, the part where the river of light grew wide and deep. They could not have guessed that they were looking toward the anchor of the whole structure, the gravitational heart that holds the galaxy together. The center lies in the direction of a particular constellation, a grouping of stars that rides low across the summer sky. The richest star clouds of that season point almost exactly at it. When you trace the Milky Way down toward that part of the sky and find the place where it grows brightest and most tangled, you are facing the core. Everything in the galaxy, including our own sun, slowly circles that point. It is the still center of an immense and turning wheel, and we are riding that wheel from far out near its edge. The distance to the center is difficult to hold in the mind. It is roughly 26,000 light-years away. A single light-year is the distance that light travels in 1 year, moving at the fastest speed there is, and it is already a span that dwarfs anything in human experience. 26,000 of them laid, end to end, is the gulf between us and the core. The light reaching your eyes from the center tonight, left there long ago, in an age before written history, before cities, before farming, when the first careful drawings were being pressed onto the walls of caves. That light has been traveling ever since, crossing the dark, and only now is it arriving. To look at the center is to look deep into the past. We do not sit anywhere near that center. Our sun lies far out in the flat disk of the galaxy, a little more than halfway from the middle to the visible edge. It is a quiet and unremarkable position, a suburban seat in the great city of stars, neither at the bright and crowded heart nor at the lonely rim. From here, the center is a distant glow, and the edge is a fading thinness in the other direction. We are simply one of many hundreds of billions of stars, drifting along in the slow rotation of the disk, bound to the center, across an almost unimaginable distance. There is a reason that the band of the Milky Way looks so crowded and so clouded in the direction of the center. Because we live inside the flat disk and look along it toward the middle, our line of sight passes through the greatest possible thickness of the galaxy. In other directions, we look up out of the disk quickly, and the stars thin out, and we see past them into the dark beyond. But toward the center, we look the long way, straight through layer upon layer of stars and gas and dust, all stacked along a single line that runs deep into the heart of the wheel. That is why the glow is so thick there, and why it is also so streaked with darkness. For if the galaxy were perfectly clear, the center would be a glory in our sky. It would blaze with the gathered light of its tremendous crowd of stars, a brilliant patch brighter than anything in the night, except the moon itself. But it does not blaze. It glows softly, dimmed and veiled, hidden behind something that stands between us and it. And that something is dust. Between us and the core lie vast clouds of fine interstellar dust, made of grains far smaller than anything you could see, smaller even than the particles of smoke. These grains drift in the cold space between the stars, gathered into great dark clouds and thin hazes that hang all along our line of sight toward the center. When the visible light of the core travels outward and runs into these grains, it is scattered and absorbed. Some of it is turned aside, some of it is soaked up entirely, and only a tiny fraction of the original light ever makes it through to reach us. The center is not hidden because it is faint. It is hidden because a curtain of dust hangs across the whole distance between here and there. The dimming is severe almost beyond belief. The visible light from the galactic center is cut down by a factor of many trillions before it reaches the Earth. Of all the brilliant light the core sends our way in the colors our eyes can see, only the smallest sliver survives the journey through the dust. This is why, for so long, the center remained a mystery. Ordinary telescopes, which gather the same visible light that our eyes use, simply could not see through the veil. They looked toward the heart of the galaxy and saw only dark clouds and a dim haze, with the true center hidden somewhere behind. But the dust is not equally good at stopping every kind of light. Light comes in a wide range of wavelengths, a great span that reaches far beyond the narrow band our eyes can detect. And the longer the wavelength of the light, the more easily it slips past the dust grains without being scattered. Visible light, with its short wavelength, is blocked. But infrared light, which has a longer wavelength than the reddest light we can see, passes through the dust far more freely. It threads its way between the grains and emerges on the other side, carrying with it a picture of the center that visible light could never bring. This is why nearly everything we have learned about the core has come not from ordinary telescopes, but from instruments that see in the infrared, in colors just beyond the edge of human vision. And infrared is not the only window. Radio waves, which have wavelengths far longer still, pass through the dust as if it were hardly there at all. They flow out from the center unhindered and reach us cleanly, carrying their own kind of picture. X-rays, at the opposite end of the spectrum, also pierce the veil, revealing the hottest and most violent processes near the core. Each kind of light shows a different layer of what hides behind the dust, and together they have slowly built up a portrait of a place the eye alone could never reach. The center of the galaxy is somewhere we have learned to see, by looking in the colors we cannot perceive, by building eyes that reach beyond our own. So we can begin to answer the simplest question of all, the one a child might ask while looking up at that brightest patch of the summer sky. Why is it so bright there? The answer is that the center truly is the brightest and most crowded region of the entire galaxy, packed with more stars in a small space than anywhere else in the Milky Way. Its true brilliance is immense, and yet a curtain of dust hangs across our view of it, dimming the visible light to a soft and clouded glow. The brightness is real. The veil is what makes it a mystery. And to find out what lies behind that veil, we must travel inward, slowly, layer by layer, toward the heart of our galaxy. There is a particular quality to that band of light when you finally see it from a truly dark place. In a city, or even a small town, it is invisible, washed out by the glow of our own lights. But out where the night is genuinely dark, far from any settlement, it rises into view slowly as the eyes adjust, and it is far brighter and more detailed than most people expect. It is not a thin smudge but a broad and structured river, with bright clouds and dark rifts, knots of glow and long lanes of shadow. And the part of it that draws the eye, the part that swells widest and shines softest and deepest, is the part that points toward the heart of everything. The dark lanes that streak across that bright band are themselves part of the story. They are not gaps in the stars, not places where the galaxy thins out. They are clouds of dust, the same dust that hides the center seen in silhouette against the glow behind them. Where you see a dark rift cutting through the Milky Way, you are seeing a great cloud of interstellar dust standing between you and the stars beyond, blocking their light. The galaxy is full of such clouds, and they are thickest toward the center, which is why the bright band there is so heavily streaked with shadow. The light and the dark are woven together all along that river. It helps to picture the shape of the whole galaxy to understand our view of it. Imagine a great flattened disk of stars, far wider than it is thick, slowly turning. Now imagine yourself living on a single grain within that disk, far from its center but still embedded in its plane. When you look out along the plane in any direction, you look through the full thickness of the disk, through layer after layer of stars, and you see a bright, crowded band wrapping all the way around your sky. When you look up, out of the plane, away from the disk, you see only a few nearby stars, and then the dark beyond. That bright band wrapping the sky is the Milky Way, and the brightest stretch of it is the direction where the disk is deepest and richest, toward the center. So the simple act of finding the center in the sky already teaches us something about our place. We are inside the galaxy, not outside looking in. We cannot step back and see it whole, the way we can see a distant galaxy hanging in the dark. We see it from within, smeared across our sky, with the center hidden in its brightest and most clouded quarter. Everything we know about the heart of the Milky Way, we have learned from this awkward inside seat, peering through the dust, along the most crowded line of sight there is, piecing together the nature of the center from the faint and filtered light that manages to reach us. It is a remarkable thing that we have learned as much as we have, given where we are forced to stand. Consider too how long that pale band has watched over us, and how recently we have come to understand it. For nearly the whole of human history, the bright river across the night was simply there, in port of the dark, as constant as the stars themselves. Every people who ever looked up saw it, and every people gave it stories. They could not have known that they were looking edge-on through a great flattened wheel of stars, or that the brightest stretch of it marked the direction of the hub. They saw only the soft glow and the dark lanes, and they wondered. We are among the first to look at that same glow and know even a little what lies behind it. the wonder remains, but now it has an answer woven through it. And the answer begins with the simplest fact of geometry. We live within the disk, embedded in its plane, far from the center but squarely inside the wheel. When we look along the plane toward the hub, we look through the maximum depth of stars the galaxy can offer, layer stacked upon layer, all the way to the crowded heart and beyond. That is why the band glows brightest there. When we look in the opposite direction, outward toward the rim, the disk thins and the glow fades. And when we look up, out of the plane entirely, we quickly leave the crowd behind and gaze into the open dark beyond the galaxy. The shape of our sky is the shape of our seat inside the wheel. The dust that hides the center is the same dust that builds new worlds, and there is a quiet grace in that. The grains that block the light of the core are the raw material of planets, the fine dark stuff that gathers in cold clouds and, given time and gravity, clumps together into stones and worlds. The veil across the center is not a dead curtain, but the same substance from which the earth itself was once assembled. When we look toward the hidden heart and see the dark lanes streaking the glow, we are seeing the very material of future worlds, drifting in the cold, dimming the light of the center as it waits for its own slow gathering. So even before the journey inward truly begins, the night sky has taught us a great deal. It has shown us our place, far out in the disk of a great wheel of stars. It has shown us the direction of the hub, in the brightest and most clouded quarter of the band. It has shown us the dust that hides the center, the same dust that makes worlds. And it has set the central question before us, glowing softly overhead. Behind that veil, at the end of that crowded line of sight, something waits at the heart of the galaxy. To find out what, we must travel toward it, slowly, through layer after layer of the wheel, inward, toward the quiet center of everything. Part 2. The crowded old city of stars. As the journey moves inward from our quiet outer seat, the first thing that changes is the crowd. Out here, near the sun, the stars are spread thin. Our nearest neighboring star is more than 4 light-years away, an enormous gulf of empty dark, and the stars around us are scattered with several light-years of nothing between them. Space here is mostly emptiness, with a few distant points of light suspended in it. But as we travel toward the center, the stars begin to gather. They draw closer together and closer still, until the thin and open disk where we live gives way to a great swelling crowd of suns. This swelling is called the bulge, and it is the galaxy's old town, packed with ancient residents. The bulge is a rounded, slightly boxy mass of stars that surrounds the center on every side. If the flat disk of the galaxy is like a great thin plate, the bulge is the thick dome rising at its middle, where the plate bows outward into a rounded heap. It is not a perfect ball. Seen from the side, it has a subtly squared-off shape, a little like a peanut or a box with rounded corners. This shape is not an accident, and it is a clue to something hidden within, a long bar of stars running through the center, which we will come to in time. But seen as a whole, the bulge is a vast and rounded gathering of stars, a city rising at the heart of the galaxy. It is large. The central bulge spans something like 10,000 light-years across, which is a substantial fraction of the entire visible galaxy gathered into one rounded swelling. To cross it from one side to the other at the speed of light would take 10,000 years. And within that span are many billions of stars, packed far more tightly than anything in our own neighborhood. The crowd grows denser the deeper you go. Near the sun, stars are separated by several light-years of open space. Deep within the bulge, they are packed hundreds or even thousands of times more closely, drawn together into a dense and glowing throng. Most of the stars in the bulge are old. They are among the very first generations the galaxy ever made, formed long ago in the galaxy's youth and burning slowly ever since. They tend toward the colors of age, the soft reds and warm oranges of cooler, long-lived suns. These are stars that have settled into a steady and patient existence, shining gently across enormous spans of time. The bright blue stars, the ones that burn hot and fast and die young, are rare here. Such stars live only briefly, and the great age of their formation in the bulge has long since passed. The bulge is not a nursery full of newborns. It is a vast and aging population, a quiet old city where most of the residents have lived for nearly the whole history of the galaxy. You can try to imagine what it would be like to live there, on a world orbiting one of those old red suns deep within the bulge. The sky would be unlike anything we know. From our seat in the thin outer disk, the night sky holds a few thousand stars visible to the unaided eye, scattered points of light against a wide dark. But from within the bulge, the sky would be crowded almost beyond imagining. Thousands upon thousands of stars would fill it, many of them bright enough to cast faint shadows on the ground. The nearest neighbors would blaze like distant street lamps, steady and brilliant. True darkness, the deep black night we know, would be almost impossible to find. There would always be some glow, some scattered light from the great throng of nearby suns. Such crowding has its consequences. In a place where stars are packed so closely, they pass near one another far more often than they do out here in the quiet outskirts. A star drifting through the bulge will, over the long ages, find other stars swinging close by, their gravity tugging at it and at anything that orbits it. These close passes can disturb planetary systems, nudging worlds onto new paths and flinging distant comets loose from their gentle orbits. The center is a more eventful neighborhood than ours, a place where the slow gravitational conversation between stars is constant rather than rare. And yet, even here, the stars almost never actually touch. It is worth holding on to this, because the image of a crowded center can make it seem as though stars must be colliding constantly, smashing into one another in the throng. They do not. Stars are tiny compared to the distances between them, even in the densest crowds. A star is a small, bright point in a vast, dark room, and even when the room is full of such points, they are still mostly separated by emptiness. Direct collisions between stars remain rare even in the bulge. The center is dense by the standards of the galaxy, far denser than anything near us, and still it is mostly empty space, with brilliant points of light scattered through a quiet dark. So the bulge is a paradox, in its gentle way. It is the most crowded part of the galaxy outside the very core, a great gathering of billions of ancient suns, and at the same time, it is still mostly emptiness, with each star riding its own long orbit through the throng. It is old and settled, lit by the warm colors of patient stars, and it surrounds the center like a vast rounded city built up over the whole life of the galaxy. To travel through it on our way inward is to pass through the galaxy's oldest and most populous district, and to feel the crowd thickening around us as we go. It is worth dwelling on the age of the bulge, because age in the galaxy is a kind of color. Stars announce their character through the light they give off, and the warm reds and oranges of the bulge are the signature of patience. A cool red star can burn steadily for many billions of years, sipping its fuel slowly, changing little across spans of time that dwarf the whole history of life on Earth. The bulge is full of such stars, and so it glows with a warm and settled light, the light of a population that has been here almost since the beginning and is in no hurry to leave. To look at the bulge is to look at the galaxy's deep past, still shining. The hotter, bluer stars tell the opposite story. A blue star burns ferociously, pouring out light at an extravagant rate, and it pays for that brilliance with a short life. The brightest blue stars last only a few million years, the blink of an eye in galactic terms, before they exhaust themselves and die. So wherever you see many blue stars, you know that stars have been forming there recently, because blue stars cannot be old. And in the bulge, blue stars are scarce, which tells us that the great wave of star formation there passed long ago. The bulge made its stars early and has mostly been aging ever since, a city that was built in the galaxy's youth and has grown old gracefully. Picture again the world we imagined within the bulge, with its crowded canopy of stars. Add to that picture the warm color of the light. The sky there would glow not with the cold white and blue of young stars, but with the soft amber and rose of an old population, a warm and gentle radiance filling the night. The nearest of those stars would be close enough to show as more than points, perhaps, swollen red suns hanging in the sky. It would be a sky of warm light and deep crowding, beautiful in a way our own thin and scattered sky can only hint at, and never quite dark. And remember, through all of this, the strange comfort hidden in the crowding. For all that the bulge is the most populous district of the galaxy outside the very core, for all that its stars are packed hundreds or thousands of times more tightly than ours, it is still, in the end, mostly empty. The stars are close by galactic standards, and yet still impossibly far apart by any human measure. A traveler crossing the bulge would still pass through vast reaches of empty dark between one star and the next. The crowding is real, and it shapes the place, but it never becomes a solid mass. The bulge remains, like all the galaxy, mostly quiet emptiness, lit by scattered ancient fire. There is a slow grandeur to a place like this, a sense of deep time made visible. The bulge has been turning at the heart of the galaxy for nearly the whole life of the Milky Way, its old stars circling patiently, generation after generation, rising and fading, while the great rounded crowd endures. To pass through it on our journey inward is to move through the galaxy's memory, through the oldest gathered light it holds, on our way toward the stranger and denser things that wait at the very center. It is worth picturing the transition from our neighborhood to the bulge as a slow gathering rather than a sudden boundary. There is no wall, no edge where the disk ends and the bulge begins. Instead, as you travel inward, the stars simply draw closer and closer together, the spaces between them shrinking by degrees, the crowd thickening gradually around you. The thin, scattered population of the outer disk gives way, mile by countless mile, to the dense, rounded throng of the bulge. It is a gentle deepening of the crowd, a slow swelling of the light, until you find yourself within the great old city of stars without ever having crossed a clear line. The bulge also holds, scattered through it, some of the oldest objects the galaxy contains. Tight, ancient clusters of stars, gathered into dense balls, drift through and around the central region, having survived since the galaxy's earliest days. They are among the most venerable structures in the Milky Way, populations of old stars bound tightly together, circling the center on long, slow orbits. To pass among them is to move through the galaxy's deep history, through gatherings of stars that formed when the galaxy itself was young and have held together ever since, faithful and old. And always, through the crowd and the age and the warm light, there is that same quiet truth to return to. The bulge is dense, the densest part of the galaxy outside the very core, and yet it is still mostly empty. The stars are gathered close by the standards of the cosmos, and still impossibly far apart by any human measure, each one riding its own long orbit through the great rounded throng. The crowd is real, and it shapes the place, but it never becomes solid. The bulge remains, like all the galaxy, a vast quiet emptiness lit by scattered ancient fire, turning slowly around the hidden center on our way toward the stranger things that wait deeper in. Part 3. The bar and the slow rivers of gas. Running straight through the heart of the bulge is a feature that took astronomers a very long time to recognize, and the reason is simple. We live inside the galaxy, out in the flat disk, and we see the bulge edge on, the long way through. It is hard to make out the true shape of a thing when you are standing within it and looking along its length. Only by carefully measuring the motions and the distances of the stars in the central region did the shape finally emerge. The Milky Way is not a simple pinwheel, with arms curving smoothly out of a round center. It is a barred spiral. A long, roughly cigar-shaped concentration of stars stretches across the central region, and the great spiral arms trail away from the two ends of that bar. The bar is not a solid object. It is not a rigid beam of stars locked together. It is a standing pattern in the orbits of many billions of stars, a shape that persists even as the individual stars flow through it. You can think of it a little like a traffic pattern on a busy road, where the cars are always changing, but the slow patch of congestion stays in the same place. The stars of the bar are always moving, always orbiting the center, and yet their orbits are arranged so that, taken all together, they trace out this long, elongated shape that endures across enormous spans of time. The bar is real, but it is a pattern rather than a thing. This long bar of stars does important work at the center of the galaxy. It acts like a great gravitational paddle, stirring the orbits of the stars and the gas throughout the inner region. As it turns, its gravity reaches out and pulls on everything nearby, nudging orbits, gathering material, and shaping the flow of gas across the central thousands of light years. The bar is one of the main engines that organizes the inner galaxy, and one of its most important effects is the way it moves gas. For the bar channels gas inward. Out in the disk, clouds of gas drift along on their own slow orbits, content to circle the center at a comfortable distance. But where the bar reaches them, its gravity disturbs those orbits and sends the gas sliding inward along the length of the bar, funneled down toward the center, like water guided along a channel. Over long ages, this steady inflow gathers an enormous reservoir of gas in the inner few thousand light years, a great accumulation of the raw material from which stars are made. The bar is, in a sense, the galaxy's supply line, carrying fresh material from the disk down toward the hungry center. The gas that collects there forms one of the richest concentrations of dense, cold material anywhere in the entire galaxy. It is called the central molecular zone, and it is a turbulent reservoir of molecular clouds wrapped around the core. Molecular gas is the coldest and densest kind, the sort that can collapse and condense into new stars, and here it is gathered in tremendous quantity, compressed into a relatively small volume around the center. If you could see the galaxy in the right kind of light, this zone would glow as a thick ring of cold cloud encircling the very heart of the Milky Way. The clouds in this central zone are unlike the gentle clouds in our own quiet part of the galaxy. They are denser and warmer and far more turbulent, churned up by the strong gravity and the crowded conditions near the center. Out near the sun, the clouds between the stars are calm and diffuse, drifting slowly through the dark. Near the center, the clouds are squeezed and stirred and pushed about, living in a more extreme environment in nearly every way. Conditions near the center are simply more intense than anything we know from our own neighborhood. Among these clouds, are some of the most massive and dense in the whole galaxy. A single one of them can hold the mass of millions of suns in gas, a vast brooding reservoir of material, waiting, perhaps, to become stars. These are among the largest reservoirs of star-making material the galaxy possesses, gathered here by the slow, patient work of the bar across the long ages. They sit near the center like great banks of cloud, dark and cold and immense, holding within them the potential for whole generations of new stars. The chemistry of these clouds is unusually rich as well. Drifting in the cold between the stars are not just simple gases, but a remarkable variety of complex molecules built up slowly in the dark over long spans of time. The center is busy not only in its gravity and its motion, but in its chemistry, a place where the cold clouds hold a surprising wealth of different substances, assembled atom by atom in the quiet dark. The heart of the galaxy is a richer and more intricate place the closer you look. Not a simple bright point, but a layered and complicated region, full of structure and motion and slow chemical work. So as we travel inward through the bulge, we pass through this great reservoir of cold cloud, this central molecular zone, gathered and stirred by the turning bar. It is the supply of material that feeds the very center, the slow rivers of gas carried down from the disk and pooled around the core. And somewhere within it, deeper still, the stars grow more crowded than anywhere else in the galaxy, drawing together into the densest gathering the Milky Way contains. The discovery that our galaxy is barred rather than simply spiral changed the way we picture our home. For a long time, the Milky Way was imagined as a graceful pinwheel, arms curving smoothly out of a round hub. The truth is a little more interesting. From above, if we could ever rise out of the disk and look down, we would see a long, straight bar of stars crossing the center, with the spiral arms springing from its ends and trailing away in great curves. It is a common shape among galaxies, this barred form, and ours is one of them. The bar is one of the defining features of our galaxy's true architecture. The way the bar moves gas is worth picturing slowly, because it is one of the central rhythms of the inner galaxy. Gas in the disk would, on its own, settle into smooth, circular orbits, content to drift around the center without ever falling in. But the bar disturbs that smoothness. Its gravity reaches out and pulls on the gas as it turns, and along certain paths, the gas loses some of its outward motion and slides inward, drawn down along the length of the bar toward the center. It is a slow process, unfolding across enormous spans of time, but it is steady, and over the ages it gathers a great quantity of gas into the central region. That gathered gas becomes the central molecular zone, and the conditions there are worth lingering on. The clouds are cold, as the clouds between stars always are, far colder than anything in everyday experience, and yet they are warmer and more agitated than the gentle clouds of our own neighborhood. They are squeezed by the strong gravity of the center, stirred by the turning of the bar, and pushed about by the energy of the crowded stars nearby. They churn and swirl in slow turbulence, dense and dark and restless, a great brooding bank of cloud wrapped around the heart of the galaxy. Within these clouds, the slow chemistry of space proceeds at a richer pace than almost anywhere else. In the cold and the dark, atoms drift together and bond, building up molecules grain by grain on the surfaces of the dust, assembling a surprising variety of substances over the long ages. The center holds some of the most chemically complex clouds in the galaxy, full of molecules built patiently in the quiet. It is a reminder that the center is not just a place of gravity and motion, but a place of slow, intricate work, where even the cold gas between the stars is busy in its own unhurried way. And all of this gas, gathered and stirred and enriched, is the supply from which the center feeds. Some of it will collapse into new stars, including the surprising young stars near the very core. Some of it will drift slowly inward, trickling down toward the giant at the center. The bar is the great supply line, the slow river carrying material from the wide disk down toward the hungry heart, and the central molecular zone is the reservoir where that material pools before its final fate. To understand the center, you must understand this flow, this patient gathering of gas that feeds everything deeper in. Part 4. The densest crowd in the galaxy. Inside the bulge, and inside the great reservoir of cold cloud, the stars draw tighter still. We have already passed through the most crowded city in the galaxy, the rounded swelling of ancient suns, and yet the journey is not done. For at the very center of all that crowding, the stars gather into a distinct and compact swarm, a dense ball of suns marking the exact heart of the Milky Way. This is the nuclear star cluster, and it is the densest concentration of stars anywhere in our galaxy. Millions of suns are crowded together here, within a region only a few light-years across. The numbers are difficult to feel. The nuclear star cluster holds tens of millions of stars within a span of just tens of light-years. To grasp how extreme that is, remember that out near the Sun, a single star sits alone within several light-years of empty space. Here, within that same kind of distance, there are not one star, but millions, packed together at a density thousands of times greater than anything in our neighborhood. If our quiet outskirts are a scattering of distant lamps across a wide, dark plain, the nuclear star cluster is a dense and glowing hive, every direction filled with brilliant nearby suns. In the innermost part of this swarm, the crowding reaches its peak. Within the central light year, stars are separated by distances no greater than the size of a single planetary system, the kind of span that, in our own solar system, would barely reach out past the most distant planets. The stars here are genuinely close to one another, near enough that their gravity is in constant conversation. They orbit quickly, swinging around the center on tight, fast paths, and as they go, they pass near their neighbors again and again, tugging on one another, nudging one another's orbits, trading slow gravitational influence across the ages. This is one of the few places in the whole galaxy where stars truly do pass close enough to disturb each other on a regular basis. Out in the disk, such close encounters are vanishingly rare, separated by enormous spans of time. But in the heart of the nuclear star cluster, they are part of the ordinary rhythm of the place. The stars are caught in a slow, perpetual dance, each one circling the center while also responding to the pull of all the others nearby. It is a dance that has been going on for billions of years and will continue for billions more, a constant, gentle reshuffling of orbits at the very heart of the galaxy. And yet, even in this densest of crowds, the stars still do not collide. It bears repeating because the image is so striking that it can mislead. Tens of millions of stars in a few tens of light years sounds like a place where suns must be crashing together constantly. They are not. The stars are still tiny compared to even these reduced distances between them. The cluster is dense beyond anything we know, and still it is mostly empty space, threaded through with the orbits of millions of brilliant points of light. The dance is close, but it is a dance, not a collision. There is a deeper surprise hidden within the cluster, one that has puzzled astronomers for a long time. Among the cluster's many old residents sits a population of young stars. Hot, bright, massive stars, the kind that burn fast and live only briefly, are found in the innermost region, close to the very center. This is strange, because the area around the center seemed far too disturbed for ordinary star formation to take place. the strong gravity, the turbulence, the constant tugging of nearby stars, all of it seemed to make the center a hostile place for the gentle process by which stars are born. And yet there they are, young and bright, sitting close to the heart of the galaxy. Their presence is one of the genuine open questions of the galactic core. Somehow, against expectation, young stars formed where conditions appeared to forbid it. The way they are arranged offers a clue. These young stars do not drift at random but trace out orderly disks and rings as they orbit, moving together in organized patterns. This hints that they formed together, all at once, from a single great cloud of gas that was somehow squeezed and disturbed into collapse near the center, rather than wandering in one by one from somewhere farther out. The center, it seems, found a way to build stars even in its difficult heart. Nearby, just outside the densest core, sit some of the most luminous and massive star clusters in the entire galaxy. They are packed with brilliant, short-lived stars, blazing far brighter than ordinary suns and pouring out light and energy into the surrounding space. These clusters are clear evidence that the center, for all its hostility, can still build stars on a grand scale. The heart of the galaxy is not a dead place, not a barren ruin around a dark center. It is a place where, even now, new stars are being made, where the densest crowd in the galaxy still finds room to grow. So the nuclear star cluster is the innermost city within the city, the densest gathering the galaxy contains, a swarm of millions of suns wrapped around the very center. It holds old stars and young ones, settled residents and surprising newcomers, all of them circling the same central point in a slow, eternal dance. And at the middle of that swarm, at the focus of all those orbits, sits something stranger than any star, something the whole cluster turns around. To feel the density of the nuclear star cluster, it helps to imagine shrinking the distances down to a human scale. Out near the Sun, if our star were a single grain of sand, the nearest neighboring grain would lie miles away across an empty plain. That is how sparse our neighborhood is. But in the heart of the nuclear star cluster, those same grains would be gathered close, perhaps only steps apart, a glittering crowd of them filling the space. That is the difference. The center holds the same kind of stars we know, but pressed together thousands of times more tightly into the densest gathering the galaxy contains. The orbits of the innermost stars are a marvel in themselves. They do not drift slowly the way distant stars do. They race, swinging around the central dark on tight, curving paths, completing their loops in years or decades, rather than the hundreds of millions of years our own sun takes. To move so quickly on such tight paths, they must be held by something of enormous mass at the focus, and as they swing through their closest approach, they reach speeds that are a real fraction of the speed of light. They are the fastest moving stars in the galaxy, whipped around the center by the gravity of the giant they orbit. The mystery of the young stars deserves a second, gentle look, because it captures something about the character of the center. Everything about the region near the giant seemed to forbid the quiet gathering of gas into new stars. The gravity is too strong, the environment too disturbed, the tugging of neighbors too constant. By every expectation, the innermost region should hold only old stars and the giant itself. And yet, threaded among the ancient residents, there are young hot stars, recently formed, sitting close to the very center. The galaxy found a way to build new stars in a place that should not have allowed it. The clue, as we said, is in how they move. These young stars are not scattered at random, but arranged in orderly disks and rings, all sharing a common pattern of motion. That orderliness is the fingerprint of a single origin. It suggests that they all formed together at once, from one great cloud of gas that was somehow squeezed into collapse near the center, perhaps as it fell inward and was compressed by the giant's gravity rather than torn apart by it. Instead of preventing star formation, the extreme environment may have triggered it in a single dramatic episode that left behind the ring of young stars we see today. And just beyond the densest core sit some of the grandest star clusters in the whole galaxy, blazing with brilliant young suns. These are among the most luminous gatherings of stars the Milky Way possesses, packed with massive, short-lived stars, pouring out light and energy. Their presence is proof that the center, for all its difficulty, remains a place where stars are still being made on a grand scale. The heart of the galaxy is not a barren ruin around a dark center. It is alive with light, crowded with stars old and young, still building new suns even in its difficult heart, all of them circling the quiet giant at the very middle. There is a slow beauty to the dance of the innermost stars that rewards a quiet imagining. Picture the central light year, that small region around the giant, and the handful of stars that orbit closest within it. They do not move in gentle circles. They sweep along long, elongated paths, swinging far out and then plunging back in toward the center, each on its own tilted loop. As one swings inward, it accelerates, racing through its closest approach at tremendous speed, then slows again as it climbs back out. Watch them all together over the years, and you would see a slow, intricate weaving, a set of looping paths, all sharing the same dark focus, a perpetual orbital dance about the still center. These stars are also, in a sense, the most useful objects in the galaxy, though they have no idea of it. By their motion, they reveal the giant they circle. Without them, the central black hole would be invisible, a dark point giving off no light, impossible to weigh. But the stars trace its gravity for us, drawing out the shape and the mass of the unseen giant through the curves of their orbits. They are unwitting messengers, reporting the nature of the center through nothing but the way they move. The densest crowd in the galaxy holds, at its heart, the very instruments by which we measured the dark thing at its center. It is worth holding on to the gentleness underneath all this extremity. The nuclear star cluster is the most crowded and most extreme stellar environment in the galaxy, and yet it is, like everything else, mostly quiet emptiness. The stars race, but they race through the dark, separated still by spaces vast on any human scale. They pass close, but they almost never touch. The dance is intricate and fast near the very center, and slow and stately farther out, and everywhere it is a dance rather than a collision, a slow weaving of orbits through the quiet dark around the giant. Even the most extreme place in the galaxy keeps this calm at its core. And around this innermost dance, the wider cluster turns more slowly. Millions of stars, in their tens of light years, old suns and young, settled residents and surprising newcomers, all circling the same center. Beyond them the bulge swells, and beyond that the disk spreads, and beyond that the rim fades into the dark, every layer turning about the same quiet point. The nuclear star cluster is the innermost city, the densest gathering, the last great crowd before the center itself, and at its very heart sits the giant, dark and still, the focus of every orbit, the anchor of the densest swarm the galaxy contains. Part 5. The quiet point at the center of everything. At the very middle of the nuclear star cluster, in the place where all those millions of orbits converge, sits something that gives off almost no light that our eyes could ever see. It does not shine like a star. It has no warm glow, no familiar brilliance. And yet it is there, unmistakably, because everything around it turns about it as if it were the fixed pin at the center of a wheel. For a long time, it was known only as a bright and compact source of radio waves, a small, steady point at the exact center of the galaxy, around which the whole nuclear star cluster seemed to revolve. What is most remarkable about this central point is how small and how steady it is. The stars of the galaxy drift and wander, each on its own long orbit, but this source does not move. It sits at the precise center and stays there, a fixed point that does not drift as the galaxy turns. Everything else circles it. The young stars trace their disks around it. The old stars swing past it on their long paths. The whole dense swarm of the cluster is organized about this one unmoving point. It is the still center of the great wheel, the place that everything else is arranged around. It glows, not in visible light, but in radio waves and in X-rays, the kinds of light that pass through the dust and reach us cleanly. And the glow does not come from any surface. There is no shining face to this object, no luminous body like a star. The light comes instead from hot material in its surroundings, gas that has been heated as it swirls and gathers near the center, radiating as it goes. The object itself is dark. What we see is the glow of everything caught near it, lit up by the extraordinary forces at work in that small region of space. Its position marks the precise, dynamical center of the Milky Way. When astronomers want to find the true heart of the galaxy, the point about which all the rotation turns, they find this compact radio source. It is the anchor of the whole structure, the gravitational keystone that the galaxy is built around. Every spiral arm, every star cloud, every drifting sun, including our own, is in some sense circling this one quiet point at the center. It is the still place at the middle of all the slow turning. The question, of course, is what it actually is. A small, dark object that gives off no light of its own, around which millions of stars orbit, sitting at the exact center of the galaxy. To answer it, astronomers did something patient and beautiful. They watched the stars. Over many long years, they tracked individual stars in the innermost region, following them carefully as they swept around the center on their elongated orbits. Slowly, painstakingly, the paths of these stars were traced out, and from those paths, a remarkable picture emerged. One star in particular became a kind of key. It races around the center on a tight, elongated loop, swinging in very close and then back out again over the course of years. By watching it complete its orbit, by measuring exactly how fast it moved and how sharply its path curved, astronomers could weigh the thing at the center. For the shape and speed of an orbit reveal the mass of whatever the orbit is going around. A planet circling a heavy star moves differently than a planet circling a light one, and from the motion you can read the mass. And when the mass at the center of the galaxy was finally read from the orbits of these stars, the answer was staggering. The stars closest to the center move at astonishing speeds. At their closest approach, some of them race along at a meaningful fraction of the speed of light, swinging around the center far faster than any planet circles any ordinary sun. To move so fast on such a tight curve, they must be held by something of tremendous mass. Their orbits require an enormous, invisible, compact mass sitting at the focus, far more than could be explained by ordinary stars hidden in the glare. Whatever sits at the center is heavier than millions of suns, and yet small enough to fit within the tight loops these stars trace around it. There is only one known kind of object that fits this description. Enormous mass gathered into a tiny space, giving off no light from any surface, with gravity strong enough to whip nearby stars around at a fraction of the speed of light. That object is a black hole. The center of the galaxy is anchored by a black hole, and not an ordinary one formed from a single dying star, but a giant, holding the mass of millions of suns. The quiet point that the whole galaxy turns around, the still center of the Great Wheel, is a supermassive black hole. And to understand the heart of the Milky Way, we must understand what that means. The patience required to weigh the center this way is worth admiring for a moment. Watching a star orbit the heart of the galaxy is not like watching a planet circle the sun, where a full orbit takes a year or a few years. The innermost stars take years to decades to complete their loops, and the more distant ones take far longer. To trace even a single orbit, astronomers had to watch the same stars patiently, year after year, decade after decade, marking their slow shift against the background, building up the curve of each path, one careful observation at a time. The measurement of the center was the work of many years of quiet attention, a slow accumulation of patience rewarded at last with an answer. And the answer, when it came, was not vague. From the shape of the orbits, the mass at the center could be pinned down precisely. An orbit is a kind of scale. The faster a body must move to hold its path, the heavier the thing it circles. By measuring exactly how fast the innermost stars moved and how sharply their paths bent, the mass at the focus could be read off directly, with little room for doubt. There was no need to guess. The stars themselves, by their motion, weighed the dark thing they orbited and reported a mass far too great for any ordinary object hidden in the glare. Consider what it means for a star to move at a fraction of the speed of light. Light is the fastest thing there is, crossing the distance from the sun to the earth in minutes. For a star, a whole sun, to move at even a small fraction of that speed is extraordinary. Yet the innermost stars of the galactic center do exactly that at their closest approach, swinging around the central dark at speeds no ordinary star ever reaches. It takes something of tremendous mass and tremendous compactness to whip a star around so fast, on so tight a curve. Only one kind of object will do. That object, a tremendous mass in a tiny space giving off no light from any surface, is a black hole, and not a small one. The mass read from the orbits is millions of times that of the sun, far beyond anything a cluster of ordinary stars could hide. And the space it occupies is small enough to fit within the tight loops the fastest stars trace. Enormous mass, tiny size, no shining surface. The description fits a black hole and nothing else we know. The quiet point at the center of the galaxy, around which the whole nuclear star cluster turns, is a supermassive black hole. It is a strange thing to arrive at after such a long journey inward. We came looking for what hides at the center of the galaxy, traveling through the crowd and the clouds and the dense swarm of stars. And at the very heart, we find not a brilliant fire, but a deep, dark stillness, a giant that gives off no light of its own, marked only by the glow of everything caught near it and the racing of the stars that circle it. The brightest, most crowded region of the galaxy turns around the darkest and stillest thing it contains. To understand that giant a little better is the next step of the journey. There is something quietly moving about the way the center was first understood, not through a single dramatic discovery, but through years of patient watching. Imagine returning to the same small patch of sky, season after season, year after year, tracking the slow shift of a handful of faint stars near the center, marking where each one had moved, building up its path, one careful measurement at a time. There was no shortcut. The orbits could only be drawn by waiting and watching, by letting the stars trace out their loops at their own slow pace. The weighing of the giant was an act of patience as much as insight, a long, quiet attention finally rewarded. And what that patience revealed was a thing of remarkable cleanliness. The mass at the center was not a vague estimate, but a sharp number read directly from the shape of the orbits. An orbit is one of the most honest measurements in all of astronomy, for it depends only on gravity and motion, both of which can be measured precisely. The faster a star must move to hold its curving path, the heavier the thing it circles, and there is little room for ambiguity in the relationship. So when the stars reported a mass of millions of suns gathered into a tiny space, the report could be trusted. The giant was weighed, and the scale did not lie. It is worth pausing on the strangeness of the result, even now that it is familiar. At the center of our galaxy, in the place that everything turns around, there sits an object as heavy as 4 million suns, and yet small enough to hide within the inner reaches of a single planetary system, giving off no light of its own, marked only by the racing of the stars around it and the soft glow of the gas it draws near. Nothing in ordinary experience prepares us for such a thing. And yet there it is, the quiet anchor of the Milky Way, confirmed by the patient stars that circle it, the darkest and stillest object in the brightest and most crowded part of our sky. Part 6. The Sleeping Giant. The object at the heart of the Milky Way is a black hole of extraordinary scale. It is not the kind that forms when a single massive star reaches the end of its life and collapses, the sort that holds the mass of a handful of suns. This is a giant of a wholly different order, holding the mass of millions of suns gathered into a single point of collapse. It is the gravitational keystone of the entire galaxy, and it has almost certainly been there, growing slowly across the ages, for nearly the whole life of the Milky Way. The galaxy and its central black hole have grown old together. Consider its scale. The central black hole holds roughly 4 million times the mass of the Sun. 4 million suns, all gathered into one place, all collapsed into a single point of overwhelming gravity. It is a number that resists the imagination. And yet, despite that immense mass, the black hole is physically compact. Its boundary, the surface of no return that we call the event horizon, is not large by the standards of the spaces between stars. It would fit comfortably inside the orbit of the innermost planets of our own solar system. 4 million suns worth of mass, packed into a region smaller than the inner reaches of the space around our own star. It is worth knowing, too, that as these things go, our black hole is a modest one. The giants at the centers of some other galaxies are far larger, holding the mass of billions of suns rather than millions, and some of them blaze with tremendous energy as they devour the material around them. By comparison, the black hole at the center of our own galaxy is small and remarkably quiet. It is not raging. It is not blazing. It sits at the center, vast and dark and still, more a sleeping giant than a roaring one. The heart of our galaxy is anchored by one of the calmest of its kind. To understand what a black hole truly is, it helps to set aside some of the more frightening images and look at it plainly. A black hole has no solid surface. There is nothing to land on, no shining face, no body in the ordinary sense. What it has instead is the event horizon, a boundary in space rather than a physical surface. The event horizon is the place where gravity becomes so strong that nothing can escape from within it, not even light, the fastest thing there is. Anything that crosses that boundary is cut off from the outside universe completely, gone beyond any possibility of return. The event horizon is not a wall but a threshold, a one-way door in the fabric of space. Around that horizon, the gravity is so strong that it bends the very paths that light travels. Light no longer moves in straight lines here, but curves and wraps around the black hole, following the deep bending of space near so much concentrated mass. The glow of the hot gas swirling near the center is gathered and warped by this bending, wrapped into a bright ring of light surrounding a dark central region. That dark region is the black hole's shadow, the silhouette it casts against the glowing material around it. It is important to understand what that shadow is and is not. The shadow is not the black hole itself, exactly. It is the dark circle that the black hole carves out of the surrounding glow, the place where light has either fallen in or been bent away, leaving a darkness ringed by brightness. When we picture a black hole, this is the image to hold, not a hole torn in space, but a dark circle surrounded by a ring of light, the glow of everything caught near it wrapped around the central dark. And this is no longer only a matter of theory or of orbits read from afar. Through patient, world-spanning observation, linking instruments across the whole face of the Earth into a single great eye, astronomers have now captured an actual image of this ring of light around our galaxy's central shadow. It is a faint and glowing circle, soft and a little uneven, with a dark center, and it confirms directly what the orbiting stars had long implied. The thing at the center is exactly what the motion of the stars said it must be. Seeing it, after weighing it for so long through the dance of the stars around it, was a quiet kind of confirmation. The ring appears just about the size it should for a black hole of 4 million solar masses. The mathematics that describes how gravity bends light worked out long before anyone could test it at the center of the galaxy, predicted how large that ring would look from our great distance. And when the image was finally made, the ring was the predicted size. It is a quiet confirmation that the laws of gravity hold even here, even around the most extreme object in the galaxy, even at the very heart of the Milky Way. So this is what hides at the center of the galaxy. Not a blazing fire, not a roaring engine, but a vast and quiet black hole, a sleeping giant holding the mass of millions of suns in a compact dark point, ringed by the soft glow of the material around it. It is the still center that everything turns about, the place where motion finally stops, the deep and silent anchor of the whole turning wheel of the galaxy. There is something restful in it when you set the fear aside. It is simply the calmest and most permanent thing in the galaxy. Sitting at the center, holding everything together, asking nothing, doing nothing, but being still. It is worth sitting for a moment with the sheer compactness of the giant. 4 million suns is a quantity of mass that resists the imagination, and yet all of it is gathered into a region that would fit within the inner part of our own solar system. If you could somehow set the central black hole where our sun is, its boundary would not reach much past the orbits of the nearest planets. All that mass, the equivalent of 4 million stars, pressed into so small a space that it nearly vanishes against the scale of the galaxy. The center hides its enormous weight inside a tiny dark point. The idea of the event horizon rewards slow thought, because it is gentler and stranger than the frightening images suggest. It is not a surface you could touch, not a wall you could strike against. It is a boundary defined entirely by the behavior of light. Inside it, gravity is so strong that no path leads back out, not even the path of light itself. Outside it, escape is still possible. The horizon is simply the dividing line between the two, a threshold in space rather than a thing in space. There is nothing there to feel, no edge to bump against, only the quiet mathematical line beyond which the outside universe can no longer be reached. The bending of light near the horizon is what gives the black hole its visible form. Light passing close to so much concentrated mass does not travel straight, but curves, following the deep bending of space itself. The glow of the hot gas swirling near the center is gathered up by this bending and wrapped into a bright ring, with a dark region at its heart where light has fallen in or been bent away. This dark region is the shadow, and the ring is the warped glow of everything caught nearby. It is a portrait drawn by gravity, the shape of the giant traced out in bent light. To have actually captured an image of that ring is one of the quiet triumphs of patient observation. It required linking instruments scattered across the whole face of the Earth into a single vast eye, all of them looking together at the same small point at the center of the galaxy, gathering faint light through the dust over long stretches of time, and then carefully assembling everything into a single picture. What emerged was a soft, glowing, slightly uneven ring with a dark center, just as the bending of light around a giant of 4 million suns predicted. The image confirmed directly what the racing stars had long implied, and the size of the ring carried its own quiet confirmation. The laws that describe how gravity bends light, worked out long before anyone could test them at the heart of the galaxy, predicted exactly how large that ring should appear from our great distance. When the picture was finally made, the ring was the size it should be. It was a small, beautiful agreement between prediction and reality, a sign that the same laws of gravity that govern a falling apple or an orbiting planet hold true even around the most extreme object in the galaxy. The giant at the center plays by the same rules as everything else, only turned up to an extraordinary degree. It is a gentle paradox that the most extreme object in the galaxy is also, in a way, the simplest. A black hole can be described almost entirely by just a few numbers, its mass chief among them. It has no surface to map, no weather to track, no complex interior to chart. It is, from the outside, a clean and minimal thing, defined by its mass, by how fast it turns, and by little else. All the richness associated with it, the glowing rings and the racing stars and the swirling gas, belongs to the surroundings, not to the giant itself. The giant is a quiet simplicity at the center of an elaborate dance. To picture the event horizon rightly, set aside the idea of a wall and imagine instead a kind of horizon in the ordinary sense, the line beyond which you cannot see. Just as the curve of the Earth hides what lies beyond the horizon from a ship at sea, the bending of space hides what lies beyond the event horizon from the outside universe. There is no barrier there, nothing to strike, only a threshold past which no signal can return. A traveler crossing it would notice no wall, no sudden edge, only that the way back had quietly closed. It is a horizon of knowledge as much as a boundary of space, the edge of what the outside can ever learn. The glow that rings the giant comes from the simple fact of gas falling inward, and there is a slow drama in it. Material drawn toward the black hole does not fall straight in. It spirals, swirling around the center in a flattened disk, crowding and heating as it goes. The closer it gets, the faster it moves and the hotter it grows, until just before it crosses the threshold, it shines fiercely, pouring out light as a last bright signal before it vanishes from view. The brightness of a black hole is really the brightness of this farewell, the glow of matter in its final spiral, lit up just before it slips beyond the horizon forever. And around our own giant, that glow is faint, because little is falling in. The disk of swirling gas is thin and quiet now, the farewell glow dim, the giant barely fed. But the soft ring captured in that hard-won image is exactly this, the bent light of the little gas that still gathers near the center, wrapped by gravity into a luminous circle around the dark. It is a small, steady, beautiful thing, the visible mark of the quietest giant in the galaxy, the soft glow of the heart of the Milky Way, drawn out by gravity against the long dark. Part 7. A giant that stirs in its sleep. For all its tremendous mass, the black hole at the center of our galaxy is unusually calm. This is one of the gentlest surprises of the whole story. We tend to imagine a black hole as a ravenous thing, endlessly pulling matter into itself, blazing with the energy of everything it consumes. And some black holes do behave that way, the great giants at the centers of certain other galaxies, drawing in vast streams of gas and shining across the universe as a result. But ours does not. It is not actively devouring large amounts of material, and so it does not blaze. Most of the time it simply sits, sipping faintly at the thin gas that drifts near it, glowing only dimly for something so massive. The reason is a kind of quiet truth about black holes. A black hole is only as bright as what falls into it. The black hole itself emits no light. All the brilliance associated with black holes comes from the material gathering and heating as it spirals inward, glowing fiercely just before it crosses the threshold. When a great deal of material is falling in, the black hole is surrounded by a blazing disk of hot gas and shines tremendously. But when only a trickle of gas reaches it, as is the case at the center of our galaxy now, there is little to heat and little to glow, and the black hole stays dim and quiet. Ours is dim because, at present, it is barely being fed. It is not entirely still, however. Now and then the center flares. There are brief brightenings, sudden gentle increases in the X-ray and infrared glow that come and go over the course of hours. These flares are thought to come from small clumps of gas that swing close to the black hole and are heated as they go, flaring up briefly before fading away or falling in. They are modest events, nothing like the blazing of an active galaxy, but they are real, and they show that the giant is not perfectly asleep. It stirs, now and then, in its long rest. A clump of gas drifts too near, brightens for a while, and then the center settles back into quiet once more. These flares fade as quickly as they come. They are brief stirrings, small disturbances on the surface of a deep calm, and after each one, the center returns to its usual stillness. The overall picture is of a giant that sleeps lightly, mostly quiet, occasionally shifting, never truly waking. It is a far cry from the violent image one might expect of a black hole holding the mass of 4 million suns. The reality is gentler and stranger, and in its way more peaceful. And yet there are signs that the center was not always so quiet. Reaching out from the heart of the galaxy, high above and far below the flat plane of the disk, are enormous structures that hint at a louder past. They are vast bubbles of hot gas and energetic particles, spanning tens of thousands of light years, arching out from the center like great wings. They are far too large and far too energetic to have been made by the quiet center we see today. They appear instead to be the remnants of some past episode of activity, a time when the center released far more energy than it does now, blowing these great bubbles outward into the space above and below the galaxy. What caused that past outburst is not entirely certain. It may have been a time when the black hole was being fed more heavily, drawing in a great deal of gas and blazing as a result, driving powerful outflows into the surrounding space. Or it may have been a tremendous burst of star formation near the center, a great wave of brilliant short-lived stars whose combined energy blew the gas outward. Perhaps it was some combination of the two. But whatever the cause, the bubbles stand as silent monuments to a more energetic chapter in the history of the center, a time when the now sleeping giant, or the crowded region around it, was far more active than it is today. These great bubbles glow softly in gamma rays and in X-rays, the highest energy kinds of light, and they arch high above and below the plane of the galaxy in a vast and symmetric pattern. They are quiet now, slowly expanding and cooling, fading remnants of whatever event created them. But they are a reminder that the center is not static, that it changes over the long ages, cycling between quiet and active phases depending on how much material finds its way inward to feed the heart of the galaxy. For that is likely the rhythm of the place, played out over spans of time too long for any single observer to witness. When gas is plentiful and flowing inward, the center grows active, the black hole is fed, and it brightens, perhaps driving great outflows like the bubbles we see today. Then the supply dwindles, the feeding slows, and the center settles back into the long quiet we find it in now. If a large cloud of gas were ever funneled down into the core, the sleeping giant could stir more strongly, even wake for a time, and the center would brighten dramatically before quieting once again. But these are slow events, unfolding across millions of years, and for now, the center rests, dim and calm, a giant breathing slowly in its sleep at the heart of the turning galaxy. There is a quiet logic to why our central giant is so dim, and it rewards a slow look. A black hole produces no light of its own. Everything bright about a black hole comes from the material around it, gas that heats up as it crowds inward and glows fiercely just before it crosses the threshold. So the brightness of a black hole is really a measure of its meal. A well-fed black hole, surrounded by a great inflowing disk of gas, blazes across the universe. A poorly fed one, with only a trickle of gas reaching it, stays dim and quiet. Our giant is dim because, for now, it is barely eating at all. The flares that come and go are the giant's only visible restlessness. Every so often the central glow brightens a little, in X-rays or in infrared, for a span of hours, and then fades back down. These brief stirrings are thought to come from small clumps of gas that wander close to the black hole and are heated as they swing past, flaring up before they fade or fall in. They are gentle events, modest brightenings rather than violent outbursts, and they show that the giant is not in a perfectly dreamless sleep. It shifts, now and then, as something drifts too near, and then it settles again into the deep quiet. The great bubbles, above and below the galaxy, are the strongest evidence that the center once lived a louder life. They are enormous, reaching tens of thousands of light-years out from the disk, far too large and energetic to have been made by the calm center we see today. They appear to be the remnants of some past episode, when the center poured out far more energy than it does now. Whether the black hole was being fed more heavily then, blazing as it consumed a great inflow of gas, or whether a tremendous burst of star formation drove the gas outward, or some mixture of both, the result was the same. Something at the center blew these vast bubbles outward into the dark. They glow now only faintly, in the highest energy light, arching above and below the plane of the galaxy in a great symmetric pattern. They are slowly expanding and cooling, fading remnants of an ancient event, silent monuments to a more energetic chapter in the center's history. We can see them, and we can read in them the memory of a louder past, but we are still piecing together exactly when they were made and exactly what made them. They are a message left behind by the center, and we are still learning to read it fully. So the picture of the center that emerges is not of a steady, unchanging thing, but of a giant that breathes slowly across the ages. When gas is plentiful and flows inward, the center grows active, the giant is fed, and it brightens, perhaps driving great outflows. When the supply dwindles, the feeding slows, and the center sinks back into the long quiet we find it in now. It is a rhythm played out over millions of years, far too slow for any single observer to watch, but written in the structures left behind. For now, in our brief moment, the giant rests, dim and calm, breathing slowly at the heart of the turning galaxy. Part 8. What it would be like to be there. It is natural, after traveling so far inward, to wonder what it would actually be like to be there, deep in the heart of the galaxy, standing on some imagined world near the center. The mind reaches for an image of fire and danger, of a place too extreme to survive. But the honest answer is gentler than that. The center is indeed extreme by every ordinary measure, and yet it is not the inferno one might imagine. It is crowded and energetic and bathed in more radiation than our own quiet corner, and at the same time it is still, by everyday standards, mostly empty space and quiet dark, with brilliant points of light scattered through it. The sky from such a world would be the most extraordinary thing about it. From here, near the sun, our night sky holds a scattering of stars against a wide dark. But from a world near the center, the sky would be a dense and glowing canopy. Thousands upon thousands of stars would fill it, many of them bright and near, some blazing with the brilliance of the young massive stars that gather there. Glowing clouds of gas would drift across the view, lit from within and from without. The soft structure of the inner galaxy would fill the dark in every direction, a sky so rich and so crowded that it would seem to press close all around. There would be beauty there, beyond anything our own modest sky can offer. It would not be a comfortable place for life as we know it. The radiation levels near the center are far higher than near our sun, the combined output of all those crowded, brilliant stars, along with the occasional flares from the center itself. And the close passes by neighboring stars, which we spoke of earlier, would be a recurring feature of any long-lived world there, now and then disturbing its orbit or its sky. The center is simply a more eventful neighborhood than ours, busier and brighter and more exposed. It is a place to marvel at, from a safe distance, rather than a gentle home. But the black hole itself, the great dark giant at the very center, would not loom over such a world the way one might fear. Unless a world drifted very close to it, far closer than any ordinary orbit would bring it, the black hole would be just one more point of interest in a crowded sky, marked perhaps by the soft ring of glowing gas around it, but otherwise quiet and distant. Its reach, though immense, is local. Its overwhelming gravity dominates only the region very near it, the innermost light years where the fast stars race around. Farther out, its influence fades into the general gravity of the galaxy, and worlds there orbit serenely, in no danger at all of being pulled in. This is perhaps the most reassuring truth of the whole journey, and it is worth holding on to as the night grows late. The galaxy as a whole orbits the center from a safe and stately distance. The black hole does not reach out across the galaxy to pull things in. It holds the center, and everything else circles it from far away, bound to it gently by the same gravity that holds a planet to its star. Nothing is falling in. Nothing is being devoured from afar. The great wheel simply turns, slowly and steadily, about its quiet, dark hub. Our own sun is part of that turning. It orbits the center of the galaxy at a comfortable remove, far out in the disk, carrying the Earth and all the planets along with it. And it does so slowly, with enormous patience. A single orbit of the sun around the center of the galaxy takes hundreds of millions of years to complete. Since the sun first formed, it has made only a handful of these great laps. The dinosaurs, in their time, rode the sun partway around a single one of them. We are bound to the center, gently, across spans of time so long that a human life, or all of human history, is barely a moment within them. And in all that slow turning, there is no danger. We are not drifting inward toward the center. We are not being drawn toward the black hole. We are simply circling, as we have always circled, held in a wide and gentle orbit by the gathered gravity of the galaxy. The center keeps its place, and we keep ours, and the great wheel turns on, carrying us around once every few 100 million years, in a journey so slow and so steady that we never feel it at all. The heart of the galaxy is extreme and crowded and strange, and yet, from our safe and distant seat, it asks nothing of us but to keep turning quietly along with everything else. Let us linger a while on that imagined sky near the center, because it is one of the gentlest images the whole journey offers. Stand on a quiet world somewhere in the inner galaxy and look up. There is no true night there, not the deep black we know, but a soft, perpetual glow, the gathered light of thousands of nearby stars. Some hang close and bright, warm points that never quite let the darkness fall. Glowing clouds of gas drift across the view, lit from within. The whole structure of the inner galaxy fills the sky, layer behind layer, a richness of light that our own thin and scattered heavens can only suggest. It would be a sky to lie beneath and lose yourself in. It would not be a gentle place for fragile life, and there is no need to pretend otherwise, but the dangers are the quiet kind, the kind that play out across long ages rather than in any sudden catastrophe. The radiation is higher there, the steady output of a crowded, brilliant neighborhood. The close passes of neighboring stars come more often, now and then disturbing a world's orbit or its distant comets. These are slow hazards, the background conditions of a busier district, not looming threats. The center is more exposed than our sheltered corner, but it is not a place of constant disaster. It is simply more eventful, lived at a slightly higher pitch. And the giant itself would not loom. This is the part most worth holding on to. Unless a world drifted improbably close, the central black hole would be just one more feature of a crowded sky, perhaps marked by a soft ring of glowing gas, otherwise quiet and distant. Its tremendous gravity dominates only the innermost region, where the fast stars race. Farther out, its pull blends into the general gravity of the galaxy, and worlds orbit calmly, never drawn toward the center. The giant holds the heart. It does not reach across the galaxy to seize what circles it from afar. This brings us to the deepest reassurance of the whole journey. The galaxy orbits its center serenely, from a safe and stately distance, and our own sun is part of that calm rotation. We are not drifting inward. We are not being pulled toward the dark. We are simply circling, as we always have, held in a wide, gentle orbit by the gathered gravity of the galaxy, in no danger whatsoever of falling in. The center keeps its place, and we keep ours, across spans of time so vast that all of human history is the smallest fraction of a single lap. For our sun takes hundreds of millions of years to circle the center once, carrying the Earth and all the planets quietly along. Since the sun was born, it has made only a handful of these great slow laps. Whole ages of the Earth have passed within a single one of them. We ride this immense and patient orbit without ever feeling it, bound gently to the heart of the galaxy, turning with everything else around the quiet center, in the long, slow dark, entirely safe, entirely carried, asking nothing, and in no danger at all. There is a gentle exercise worth trying in the mind as the night settles. Picture the slow orbit of our own sun around the distant center, and place yourself upon it. We are moving, always, carried along in the great rotation of the disk, sweeping around the hub of the galaxy at a steady and tremendous pace. And yet we feel nothing. The motion is so vast and so smooth that there is no sensation of it at all. The ground holds still beneath us. The stars seem fixed, and only by careful measurement can we know that we are circling the center at all. We are travelers on the longest and quietest journey there is, and we make it without ever feeling the road. The scale of that journey is almost restful to contemplate, precisely because it is so far beyond us. A single lap of the sun around the center takes hundreds of millions of years. No human will ever see even a noticeable fraction of one complete. Whole ages of the earth, the rise and fall of mountains, the slow drift of continents, the long parade of living things, all unfold within the span of a single galactic orbit. We are carried around the center on a journey so long that all of recorded history is the smallest step along it, and there is a kind of peace in being so small, a part of so vast and patient emotion. And in all of it, we are safe. This is the heart of the reassurance, the thing to carry into sleep. The center is extreme and crowded and strange, but it does not reach for us. The giant holds its place at the heart, and we hold ours far out on the rim, and the gravity that binds us is the same gentle gravity that holds a planet to its star. Nothing is pulling us inward. Nothing is drawing us toward the dark. We simply circle, as we always have, carried serenely around the quiet center by the great slow turning of the galaxy, in no danger at all. So when you look toward that brightest patch of the summer sky, and know now what hides behind it, you need feel no fear. The giant at the center is not a threat, but an anchor, the still point that holds the whole wheel together, the deep, quiet hub around which we turn in our long, safe orbit. It keeps its place, and it keeps us in ours, carrying us gently through the dark, around once every few 100 million years, asking nothing, threatening nothing, simply holding the galaxy together from its quiet center, while we ride the slow wheel around it. Part 9. The Things We Still Do Not Know. The center of the galaxy is one of the most carefully studied places in the entire sky, watched for many long years by patient instruments looking in every kind of light. And yet, for all that study, it keeps its secrets. Several genuine puzzles remain open there, not riddles of confusion or matters of dispute, but honest gaps in our understanding, the kind of quiet unknowns that make the universe feel larger and more interesting the more closely we look. There is something restful in these unanswered questions, a reminder that even the most studied place in the sky still holds things we have not yet learned. The first of these puzzles we have already met. It is the question of how the young stars came to be so close to the black hole, in a place where conditions seemed far too violent for new stars to form. The strong gravity, the turbulence, the constant tugging of crowded neighbors, all of it seemed to forbid the gentle gathering of gas into stars. And yet there they are, young and bright, near the very center. We have clues, the orderly disks and rings in which they orbit, suggesting they formed together from a single disturbed cloud. But exactly how that cloud was squeezed into stars, so near the giant, remains unresolved. The center found a way to do something that should have been difficult, and we are still working out how. There is another puzzle, stranger still, that has drawn a great deal of attention. Near the center are faint, compact objects that do not behave quite like anything else. In some ways they act like clouds of gas, drifting and stretching as they move. In other ways they act like stars, holding together as a single body. And they drift close to the black hole, swinging in near it on their orbits, and then back out again, surviving passes that should tear a simple cloud of gas to shreds. A loose cloud, pulled by the black hole's gravity, ought to be stretched and dispersed. These objects are not. What they truly are, whether they are stars wrapped in gas, or pairs of stars merged together, or something else entirely, is still genuinely debated. They are among the most intriguing residents of the center. The great bubbles that arch above and below the galaxy hold their own unanswered questions. We can see them, glowing faintly in the highest energy light, reaching tens of thousands of light years out from the center. We understand that they were blown outward in some past episode of activity. But the full story of exactly when they were made, and exactly what made them, whether the feeding of the black hole, or a great burst of star formation, or some mixture of both, is still being pieced together from the faint glow they leave behind. They are a message from the center's past, and we are still learning to read it. And there is a deeper question that connects the center to everything else, to the whole grand story of how galaxies come to be. The black hole and the galaxy around it appear to have grown up together, each shaping the other across billions of years. The size of the central black hole and the size of the surrounding bulge of stars are linked, related in a way that suggests their histories are intertwined. How exactly this happened, how a black hole at the center and the vast galaxy around it could grow in step with one another over such enormous spans of time, is one of the deep, open questions of all astronomy. The heart of our galaxy is a single example of a pattern found across the universe, and understanding it helps us understand how galaxies everywhere are made. These open questions are not signs of failure or confusion. They are signs of a frontier. The center of our galaxy is close enough to study in fine detail, the nearest such place in all the universe, and at the same time, it is strange enough to keep surprising us at every turn. It is a place where the ordinary, comfortable rules of the quiet outer galaxy give way to something richer and less familiar, where stars race at a fraction of the speed of light, and giants sleep at the center, and strange objects drift past the dark. Each thing we learn there opens a new question, and each new question draws us a little deeper into the wonder of it. There is a peace in this, if you let there be. We do not need to know everything about the center to rest beneath the glow of it. The astronomers who study it will go on patiently asking their questions, watching the stars race around the dark, reading the faint light of the great bubbles, puzzling over the strange drifting objects near the heart. And the center itself will go on as it always has, turning quietly, keeping most of its secrets, indifferent to whether we have solved them or not. The unknowns are not a problem to be anxious about. They are simply the part of the story that has not yet been told, waiting in the dark at the heart of the galaxy for someone, someday, to slowly bring it into the light. The strange drifting objects near the center deserve a slower look because they are among the most curious things in the whole galaxy. They appear as faint, compact knots near the giant, and they behave in a way that does not fit neatly into any familiar category. Sometimes they seem to stretch and spread like clouds of gas. Other times they hold together as a single body, the way a star would. And as they swing close to the black hole on their orbits, they survive passes that ought to tear a loose cloud apart, emerging stretched but intact. A simple cloud, pulled by such gravity, should disperse. These do not. They endure. What they actually are is genuinely unknown. They might be stars wrapped in shrouds of their own gas, dense enough at the core to survive the giant's pull while their outer layers spread and glow. They might be pairs of stars that have merged, or are merging, into a single object surrounded by disturbed material. They might be something else entirely, a kind of object we have not yet fully understood. They are a small, fascinating mystery orbiting the heart of the galaxy, and they are close enough to study in detail, which is part of what makes them so intriguing. The center is near enough that its puzzles can be examined closely, again and again. The history of the great bubbles is another open chapter. We see them clearly, glowing faintly in the highest energy light, reaching far above and below the disk, We understand in broad terms that they were blown outward in some past episode of activity at the center. But the details remain to be filled in. Exactly when were they made? Exactly what made them? The feeding of the giant, or a burst of star formation, or both together? These questions are being worked out slowly, from the faint glow and the subtle structure of the bubbles, a piece at a time. The center's past is written in those structures, and we are still learning to read the writing. The deepest question of all connects the center to the whole story of galaxies. The giant at the heart of the Milky Way and the great bulge of stars around it are linked in size, related in a way that hints their histories are bound together. Across the universe, the same pattern appears: central black holes and their surrounding galaxies grown in proportion to one another. How this happens, how a tiny dark point at the center and the vast galaxy around it could grow up in step over billions of years, each somehow shaping the other, is one of the great unsolved questions of astronomy. Our own center is the nearest example of a pattern that spans the cosmos, and to understand it is to understand something about how all galaxies are made. None of these unknowns should trouble the rest of a quiet night. They are not failures but frontiers, the living edge of what we are still learning. The center is close enough to study in fine detail, and strange enough to keep surprising us. And that combination is a gift. Every answer there opens a new question, and every question draws us a little deeper into the wonder of the place. The astronomers will go on watching patiently, and the center will go on keeping most of its secrets, turning quietly in the dark, holding its mysteries gently at the heart of the galaxy, in no hurry at all to give them up. Part 10. The still point of the turning galaxy. Let us step back now, at the end of the long journey inward, and see the whole of it from a distance once more. We began far out near the rim, on a quiet world circling an ordinary star, looking toward the brightest patch of the summer sky. We traveled inward through the thickening crowd, through the great rounded city of ancient stars, along the slow rivers of gas drawn down by the turning bar. We passed through the densest swarm in the galaxy, the nuclear star cluster with its millions of suns and its surprising young stars. And at the center of all of it, we found the quiet giant, the supermassive black hole, the dark and silent anchor that the whole structure turns around. The center of the galaxy is the point about which everything turns. Every spiral arm sweeps around it. Every star cloud drifts in its great slow orbit about it. Every distant sun, including our own, is bound to it across the long ages, circling patiently in the wide disk. It is the anchor of a structure so vast that light itself takes 100,000 years to cross from one edge to the other. And at the very middle of all that grandeur sits a single dark point, holding the mass of millions of suns, around which the whole immense wheel revolves. Everything in the galaxy is, in some sense, arranged around that one quiet center. It holds the whole thing together. The black hole and the great mass of stars gathered around it form the gravitational heart of the galaxy, the keystone that keeps the structure bound. Without that center, the galaxy as we know it could not hold its shape. The arms would have nothing to wind around. The disk would have no hub to turn upon. The whole slow, majestic rotation would have no point to organize it. The center is not just a curiosity hidden behind the dust. It is the thing that makes the galaxy a galaxy, the still pivot at the heart of all the turning. And it has been there for almost the entire history of the Milky Way. The center, with its giant at the middle, anchored the galaxy in its youth and has held it steady ever since, through the slow birth and death of countless generations of stars. It was there long before the sun was born, and it will remain there long after the sun has died and faded, holding the galaxy together across spans of time that stretch beyond the life of any star. It is the most permanent thing in the galaxy, the deep and patient center that endures while everything else is born and burns and fades around it. It is, in the most literal sense, the heart of our galaxy, the point that everything is built around, the still center of the turning. We have looked toward it on summer nights without knowing what we were seeing, drawn to the brightest patch of the sky, without realizing that behind that soft and clouded glow lay the anchor of everything. And now, knowing a little of what hides there, we can look toward it with a quiet kind of recognition, understanding that the brightest part of the night is also the deepest, the most crowded, the most hidden, and the most still. There is something restful in all of this, when the night grows late and the mind begins to settle. The galaxy does not need us to watch it turn. The center has kept its slow vigil for billions of years, indifferent and steady, holding everything together from the dark, and it will keep that vigil for billions more, whether or not anyone is here to look toward it. It asks nothing. It does nothing but be still and hold and turn the great wheel slowly about itself. The brightest, most crowded, most hidden place in all our sky is also the quietest, a deep dark anchor at the center of the long, slow turning. And so we leave the center of the galaxy where it has always been, turning quietly in the dark, holding everything together without ever needing to be seen. It does not need our watching, and it does not need our worry. It will keep its slow and patient vigil long after this night is forgotten, as it has through every night that ever was. Let your breathing slow now. Let the crowded sky soften into a single, gentle glow behind your eyes. Let the great wheel turn on without you for a while, carrying you gently along with everything else around the quiet center in the long, slow dark. Sleep well, and good night. Think back over the whole of the journey, all the layers we have passed through to reach this quiet center. We began on the rim, looking toward the brightest patch of the summer sky. We crossed the open outer disk, where stars are scattered thin, and entered the thickening crowd. We moved through the great rounded city of ancient suns, glowing warm and old. We followed the slow rivers of gas drawn inward by the turning bar, into the dense reservoir of cold cloud. We passed into the nuclear star cluster, the densest swarm the galaxy holds, with its racing stars and its surprising young suns. And at the very heart we found the giant, dark and still, the anchor of it all. Each of those layers is arranged around the same center. The spiral arms wind around it. The bulge swells around it. The cluster swarms around it. The fast stars race around it. And far out on the rim, our own sun circles it too, slowly, patiently, across the long ages. Everything in the galaxy is in some sense built around that one quiet point, organized by its gravity, held in its great, slow rotation. The center is not merely a curiosity hidden behind the dust. It is the thing that makes the galaxy a galaxy, the hub that all the turning turns upon. And it endures. The center has anchored the Milky Way for nearly the whole of the galaxy's life, through the birth and death of countless generations of stars, and it will go on anchoring it long after our own sun has faded. It is the most permanent thing in the galaxy, the deep and patient hub that holds while everything else is born and burns and passes. There is a strange comfort in that permanence, in knowing that beneath all the change and motion of the galaxy, there is a still center that has held steady since the beginning and will hold steady to the end. So the question we began with finds its answer. What is really hiding at the center of the galaxy? Not a blazing fire, not a roaring engine of destruction, but a vast and quiet giant, a black hole holding the mass of millions of suns in a compact dark point, ringed by the soft glow of the material around it, surrounded by the densest crowd of stars in the galaxy, veiled from our eyes by a long curtain of dust. The brightest part of our sky hides the darkest and stillest thing it contains. The most crowded region turns around the quietest center. And all of it has been there, turning, since long before we existed. There is rest in this, when the night grows late. The galaxy does not need us to watch it turn. The center has kept its slow vigil for billions of years, indifferent and steady, holding everything together from the dark, and it will keep that vigil for billions more, whether or not anyone is here to look. It asks nothing of us. It does nothing but be still and hold and turn the great wheel quietly about itself, carrying us along with it, around once every few 100 million years, in the long, slow dark. And so, before the night closes over completely, hold this one last image. The bright soft band across the summer sky, the dark lanes streaking through it, the crowded glow toward the hub, and far behind that glow, hidden by dust and distance, the quiet giant at the very center, turning everything slowly around itself. It has been there since long before us, and it will be there long after, the still dark anchor of the brightest part of our sky. There is nothing to fear in it, only something vast and patient to rest beneath as the great wheel turns on quietly in the dark.